Good morning. My name is Simon Riggs and I'm a Postgres Fellow with EDB. I'm going to be talking about the Postgres ecosystem. So what do we mean by the ecosystem? Well, obviously, PostgreSQL is a database product. It's the world's most advanced open source database. And PostgreSQL is also a project. It's the PostgreSQL.org is run by the PostgreSQL Global Development Group, or PGDG. So PostgreSQL is both a product and a project. But what I'm talking about today is more about the Postgres ecosystem itself, meaning all of the different projects that make up the Postgres landscape. And I'd like to talk to you about how all of that is funded, because that's quite an important point that quite often we don't talk about, because we tend to just focus on either database topics or open source topics. And really, we don't actually ever talk about how did that funding arise? Where does it come from? And, do we even need funding? Yeah. So that's one, that's the really the topic of today's talk is to go through some of those points. So the starting point, first of all, is to look at the community itself. What do we mean by the PostgreSQL community? Who's in it and what do they do? So typically we refer to people as hackers. That's because the hackers mailing list is one of the main lists within the Postgres community where we discuss a lot of the engineering topics that happen within the project. Now the project itself is managed by the core team. When I say managed by, it's really a supervisory team that manages all the other aspects of things. But there is also a security team, a sysadmin team, a packages team, and things like that. So the core team don't do all of the work; they're just supervising all of the different teams that do the work. But the main technical decisions on the project are taken by a group of people called the committers, meaning that they have commit rights onto the source code of the Postgres database. And then below that, we have a group that I would refer to as the contributors. These are people that put forward changes to the source code, and they discuss those changes on the hackers mailing list. But the changes that the contributors make are actually committed into the source code by that group that I just referred to, the committers. Okay. Now that's quite an important way of doing things, because obviously if we just had lots of different people putting changes into the source code, it could be quite chaotic. So the committers are there also in a supervisory role to supervise the code. And that's really what gives us our what's known as a quality gate. It's that ability to keep the good things and reflect what is not yet agreed as a good thing. And then, of course, other people are also involved who I'll call commentators. And this is really the people that will comment on things and they'll suggest ideas and such like, but they're not necessarily actively involved in writing code for the project. Now that's who we normally talk about as being the PostgreSQL community, but actually what I'd like to observe is that the hackers are actually only the most visible tip of quite a large iceberg of people. And below the commentators, I have got this lag that I've called careerists. These are people that make their career out of PostgreSQL, but that don't necessarily ever appear on lists. They don't necessarily comment anywhere, but they're very heavily involved in the Postgres product in their daily lives. So this people might be sysadmins or DBAs or people that self-identify as being heavily involved with the Postgres product. Okay, Now, so there's a point there, is that they're involved with the product, but not necessarily with the project. And that's perfectly fine. There's no reason why anybody should contribute to the project if they don't wish to. But there is a very large group of people, possibly 10 or more thousand people, that are involved with Postgres on a daily basis, and yet they're not contributing to the project. And what I'm trying to say there is that this is a group of people that we really must consider as being actually a very important part of the community, even if they don't actually speak very often. But when they do, that's when we really have to listen. And then below that, I've got another group that I've called customers. Now the customers is, what I mean is these are people that are using Postgres, but wouldn't necessarily self-identify as somebody that spends a lot of time with Postgres. And typically that would be because they see themselves more as a web developer or a Java developer or a Python developer. They don't necessarily see themselves just as a Postgres person. They're really involved in using Postgres from a variety of perspectives. Maybe they're running monitoring systems that observe how databases are going. Maybe they're helping run people's cloud stacks, or there's a variety of ways in which they can interact with Postgres. And those people are also particularly important, even if they don't even self-identify as being part of our community. We should still regard them as being part of that community because they're effectively our users. And then I've got another layer below that, which is the confused. And these are people that don't yet use Postgres and hopefully will do in the future. And there's a very important group because obviously before Postgres started, everybody was in that category, and we've just slowly moved people from that category up into the other parts of the community, and very successfully over the last 25 years. So one of my purpose here really is just to remind everybody that the Postgres community is actually an extremely large group of people with all sorts of viewpoints, all sorts of contributions to both the product and the project. Now, what does PostgreSQL deliver? What actually is the Postgres product? Well, the most important thing that Postgres delivers is stability. And that's because as a database, we need to be able to put our trust in a product that's going to look after our data. And so the Postgres project develops Postgres to a regular annual release cycle. And it does that with consistent quality because it's got a well worked out system of quality to ensure that as few bugs as possible work its way into the project. Backwards compatibility is important, and that's also what we mean by stability, in the sense that the APIs around Postgres don't change on a daily basis. They don't hardly change on a yearly basis. And so this longevity of compatibility means that we're able to attract a very wide range of other projects to get involved, to interface and integrate with the Postgres product. Over and above that, we provide long-term 5-year support for all of the releases that have been produced, and that gives us this model as shown in the diagram, where we have 5 overlapping releases, each of which is supported for 5 years, but each year we retire one old version and we introduce one new version. On top of that, the project has got very full documentation. It's got an active security team, and we also produce regular maintenance releases. So all of those things taken together provide PostgreSQL with an extraordinary level of stability that's looked to in the industry as being a real beacon for stability and dependency, or dependability. But stability is one thing, but what also we see in the Postgres ecosystem is quite a lot of agility in the way that people are introducing new things. Now, obviously, if the main product is being released on an annual cycle, that means the minimum it takes to release a new feature within the Postgres product is slightly more than a year, because you've got to think about it, you've got to talk about it, you've got to write it, and then the whole release cycle has to occur. So that can often be 18 months or even longer in many cases, especially where features are quite large. It takes then a lot of years to release some of those things out into the user base. And as a result, you'll see that a number of people have looked at different ways of producing new features for Postgres. The first way that most people attempted is doing something called a fork. Now, a fork is where people take a copy of the source code of Postgres and then they develop their own features. And unfortunately, if you add a lot of big features to a project, what ends up happening is you have a system where major changes are made to that software, but they're so major that it's really difficult to get the source code to realign. And so what you tend to see is software being forked at a particular release level and then taking many years to be updated to later levels of the software. So a fork is a good way of producing new features, but it's not a good way of maintaining new features. And generally, I think it's probably the case that Postgres project would try to discourage people from producing forks, mainly because it splits the contribution. Okay, so if we have multiple forks of the project, then we're not all putting our efforts back into one product, which moves us forwards faster. And so as a result, a number of other ways of being agile in the Postgres ecosystem have evolved. The first one of those is what I'm calling a value-added distro. There isn't really a word for this, but here we see the idea that people have taken the source code and they're maintaining a changed version of the source code over time in order to support additional features on top of Postgres. And I've got a couple of examples there of the EDB advanced server, but also timescale has in many ways changed things to that nature. But the real way that I see is of considerable benefit to the Postgres ecosystem is actually the extensibility of Postgres itself. And that has now been formalized into this concept of an extension. And that allows external projects to add significant new functionality in a fully supported way. So these extensions run directly on top of Postgres and work with it to provide this additional functionality. Most notable of those is PostGIS, which is widely recognized as the world's most advanced GIS system. But there's also additional extensions like the BDR replication and clustering extension, the AGE extension, which is about graphs and graph databases, and also the Citus scalability extension. So these are all good examples of how Postgres supports and benefits from the agility on top of the stability that's provided by the core PostgreSQL system itself. And this is particularly important because by having both mechanisms here, we get both benefits. So instead of saying it's usually a trade-off between stability and agility, we actually get both. We get the beauty of the stability and as well as all of the benefits that we get from agility. So I think that's a really good thing for the Postgres ecosystem, that we support both approaches. But where do the challenges come from in the Postgres ecosystem? Obviously, one of the big debates will always be what type of software license should projects have. Now, obviously, if people are releasing extensions or they're releasing value-added distros or forks, there's always a discussion, should that be closed source or open source, or whatever, what should the license be? The key point about that is how do we pay for these changes? And what everybody's trying to do there is to work out how to make a business out of making these changes. Now, making a business is sometimes a very contentious thing, especially when we talk about open source, because open source is supposed to be free. But my point here is that we need to talk about where the money comes from to produce open source. If we're not talking about where the money comes from, then we are just fooling ourselves, because most of the developments that are taking place are actually produced by companies. And I'll go on to look at that statement in more detail in the next couple of slides, so we can actually see what's going on there. But why would we care about money anyway? I mean, who cares about money, right? Well, the thing is, our competitors and people that are challenging the Postgres project are in many cases borrowing millions and millions, in some cases 60 million, another case 100 million. I think there was another case of 270 million. So people are borrowing big money in order to enhance their database systems. And if PostgreSQL is serious about continuing to be the world's most advanced database, then we have to look at where the funding is coming from in order to understand how we're going to move the world forwards and stay at the very top of our game for many years to come. And that's a question that I'd like to consider next. So the Postgres ecosystem is very wide, it's truly international and very diverse. But Postgres must look outwards in order to meet the challenges or the challenges that we see, rather than consider everything in a much more internal, inward-facing way. So if we want to move the world forwards, then what we need to consider is, how does that actually occur? What does progress look like? Well, to me, progress is code, okay? Now, some people have said, well, code isn't the only contribution you can make to a project, and I would agree. But code is the thing that is moving the project forwards. If there's no code, then there's no progress, okay? You might have an awful lot of heat and light elsewhere, but no code, no progress. So we must consider the code to be the currency of change. And so my questions then are, who writes the code and who pays for it? And that's what I seek to look at over the next few slides. So, as I mentioned before, PostgreSQL committers are the people that eventually commit the code through to the source code repository, and they're the people that are primarily responsible for the quality within the project. Now, there's currently 29 people who have commit rights over the PostgreSQL source code. There have been in the past slightly more than that, but I don't think that's a particularly important point. The point here is that there's around 30 people that have got access to the source code, and those are the people that are responsible for making sure that Postgres is a quality project. Now, of those 29 people, going through the list of people that I know and knowing what they do and who they work for, I've assessed that as about 26 out of 29 people are actually full-time PostgreSQL professionals working for companies that get revenue from Postgres itself via products and or services that that company offers to its customers. Okay, now that's quite a high proportion, and I consider that a good thing. Okay, because professional people, by which I mean full-time people, really are the backbone of any organization. Okay, volunteers can contribute quite a lot, but you still will always need full-time professional staff in order to move things forward, whether that's a charity or whether it's a software product or whatever. Okay, you cannot rely just purely on volunteers in order to get absolutely everything done. Now, interestingly, of that 29, actually only 18 people are full-time developers. Okay, so that means that there's some other people that are committers that are involved in a variety of other roles, whether that's a sort of management or evangelism or that kind of thing. So there's a whole range of different ways that people contribute, even at this level. So what I've done then is to have a look at things from a perspective of EDB and Second Quadrant, which was the company that was recently acquired by EDB and which with which I served for many years. So of those 29 committers, 16 of them have worked for the now expanded EDB organization. So that's actually 55% of committers have worked for EDB and or Second Quadrant at one stage or other. Now, there's only actually 6 committers working for EDB at the moment, and that means that people have spread out across quite a wide range of companies, which is a very good thing. Now, EDB and Second Quadrant started contributing around 15 years ago, and over that point, 19 people have been made committers on the Postgres project. Now, that's a very good thing, because that's actually saying that 2/3 of the people that are currently committers have been made committers in the last 15 years. Or another way of putting it is to say that the number of people that are committers has expanded by a factor of 3 over the last 15 years, which is an extremely good thing and shows that both the depth of people's contribution, but also the fact that the project's becoming more popular and the range of skill is expanding. Now, of that 19 people, 11 of those people became committers while they were working for EDB and or Second Quadrant. And that works out to be 58% of committers have come up the ranks in the community as a result of EDB's contribution. So what this tells me is something that I'd like to highlight to everybody, because typically, as I said before, when we're talking about open source, people often regard the involvement of companies as some kind of negative aspect. And what I'm reminding everybody here is that the contribution that EDB has made across the last 15 years has demonstrated long-term commitment and the development of new talent for the project that has been really pivotal to the expansion of the project itself. Now, obviously, I work from EDB, and you're probably thinking I'm only saying this because we're working for EDB. But my point here is really to understand this point, in that industry is actually really pivotal to the Postgres project itself, and in many cases to many other open source ecosystems. So the community is incredibly important here. The wide, diverse range of individuals that contribute to the organization is what makes open source better than closed source as an engineering mechanism. Okay, very definitely. And that's why community is first here on my list. But community plus industry is the thing that really makes the project move along smoothly, because it's by having full-time professional engineers involved in the project doing the majority of the heavy lifting work that allows the project to move along. And so what I want to remind you here today is that the Postgres project and many other open source projects depend on both community and industry in order to make things work. And that's why over the last few years, I've begun to see the important contributions that industry have made to the project, not just from the perspective of the companies I've worked at, but the perspective that involving a wide range of companies into the ecosystem of Postgres is what's driving the project forwards. Okay, and that is an interesting perspective, and it's probably one that I'm almost uniquely able to make as being somebody that's actually run a heavy contributing company to Postgres, because not necessarily people wouldn't necessarily know exactly how that contribution is funded from these different companies. But anyway, Postgres is definitely what brings us all together. And what I'd like to end on is the thought that we all taken together support the PostgreSQL mission, which I'm restating here as being, we are the guardians of the world's most valuable commodity, data. And it's that respect for the users of data and the respect for getting the right answer that has driven PostgreSQL to be the top database that it is today. So thank you very much for listening to my overview of the PostgreSQL ecosystem. I really hope that you enjoy the rest of the conference. It's going to be pretty good. I hope to attend many of the talks myself. Obviously, as I said, from a wide range of companies, and that's what makes the PostgreSQL ecosystem great. Thank you very much.